Poppet. We are discussing compaction. In first video of compaction, we have seen compaction, consolidation, difference between compaction and consolidation, as well as effects of compaction on different soil properties. Now let us move to standard Proctor test. From that we can get MDD, OMC, etc. Then we will move further. Let us start our session. Standard Proctor test. Basically, this is a standard Proctor test assembly. This is a base plate which is detachable, as well as this is collar. These both can be attached with each other. This is our Proctor hammer. Weight of this hammer is approximately 2.6 kg. Diameter of that is 50 mm. Here, after connecting both of them, the hammer will compact the soil. Let us understand the step-by-step procedure for standard Proctor test. We have to take 20 kg soil passing from 4.75 mm IS first. We have to add 4% water if the soil is sandy. But if the soil is clay, we have to add 8% water content. After adding water content, we have to let the soil set. After that, we will grease the mold and then we will weigh the empty mold and give name as mass M1. Then we will take 2.5 kg of soil. We will fill it in 3 equal layers and we will compact it with this Proctor hammer with 25 number of blows. After that, we will remove the collar. Collar is this portion. Then we will trim off the extra soil with straight edge instrument, straight edge device. After removing extra soil, we will weigh the soil and tell it mass M2, which will be mass of compacted soil plus the mold. After that, we will send some soil for water content determination, and furthermore we will increase 3% of water content and repeat the steps. This way we can take 5 to 7 different number of samples so that we can calculate accurate MDD and OMC for a soil. Then determine bulk density and dry density. So this is how standard Proctor experiment is done. After measuring M1, M2, etc. details, we will prepare an observation table like this. In observation table, we have to put M1, mass 1, which is mass of empty mold, in grams for sample number 1. We should take sample up to 5 number of sample. Mass of empty mold plus compacted soil M2 in grams. So M1 and M2, which we have measured earlier, we have to put it here. Then we will remove empty mold mass and we will get total compacted soil mass. Then we will find out bulk density as per this formula. We will put water content here and dry density here. This way we can note all 5 sample details. After noting these 5 sample details, after that we can prepare this kind of graph which is showing dry density versus moisture content. In this graph we can denote the different points which we got from experiment, and we can get MDD and OMC from this curve. So standard Proctor test is to determine optimum moisture content and maximum dry density of any soil. Let us move further. Let us understand light compaction and heavy compaction difference. When we are compacting in a light manner, mass of hammer is taken as 2.6 kg, but in heavy compaction, mass of hammer is taken as 4.89 kg. Height of free fall in light compaction is 31 cm, where height of free fall in heavy compaction, that is 45 where in light compaction dimension of the mole are diameter 100, height 127.3 mm and volume of the cylinder is 1000 centimeter cube, which will be same in heavy compaction too. In lighter compaction, 3 layers of soil is filled, where in heavy compaction 5 layers of soil is filled. After that, the total energy of compaction, or we can say compactive effort in light compaction, that is around 592 kilojoule per meter cube, where in heavy compaction that is higher, much higher, that is 2700 kilojoule per meter cube. Where light compaction, for giving light compaction, standard Proctor test which we have just seen that it is used, where for heavy compaction modified Proctor test is used, in which these details should be there. Let us move further. Factors affecting compaction. So water content and how it will affect compaction. Let us see that. So at lower water content the soil is stiff. It will be stiff at lower water content. It will not move much and offers more resistance to compaction. So it will offer more resistance. But if you provide more water content, as the water content is increased, the soil particles get lubricated. So soil particles are in movement as you give water to it. The soil mass becomes more workable, so it can flow, and the particles have closed packing due to that, so that compaction will affect more at higher water content. Let us move further. Amount of compaction. So how much compactive effort you are giving, it will affect. Let us see. The amount of compaction greatly affects the MDD and OMC of a given soil. The effect of increasing the compactive energy result in an increase in MDD and decrease in OMC. That means how much higher you are giving compaction, it will decide its MDD increment and OMC decrement. So this is how amount of compaction will affect. Let us move further. Type of soil. Maximum dry density is achieved according to the soil type. Let us see this graph, dry density versus water content. Here maximum MDD is achieved of well graded sand. MDD compared to low plasticity silt, low plasticity clay and high plasticity clay, well graded sand will be having highest MDD. So this is how type of soil matters. Let us move further. Method of compaction. Which method you are adopting, that is also important here. The dry density achieved also depend upon the method of compaction. For the same amount of compactive effort, if you are applying same compactive effort, the dry density will depend upon whether the method of compaction utilizes kneading action, dynamic action or stationary action. Stationary actions mean static action. Dynamic action means it is moving, and kneading action means it is vibrating kind of thing. It is making particles alive. Let us move further. Thickness of layer. In the compaction of soils, the thickness of soil layer also play an important role. Normally, the thickness of layer in the laboratory is kept 30 to 40 mm, while in the field thickness of layer is kept about 200 to 300 mm. So thickness of layer kept in laboratory as well as field, both are different. So please be attentive here. Let us move further. The lesser thickness of soil layer gives higher dry density. So lesser thickness of soil will give higher MDD. Let us move further. Saturation line. If all the voids are removed from the soil by compactive action, the soil becomes fully saturated and higher MDD is achieved. So saturation line can be achieved when by compactive action you remove all the voids, that is 100% saturation, which is not practically feasible or possible. Let us move further. Admixtures. The compaction characteristics of the soils are improved by adding some admixtures. So if you add some chemicals in the soil, it will improve its MDD as well as decrease its OMC. The most commonly used admixtures are lime, cement and bitumen. So these are most common admixtures. Let us move forward. Stone content. With addition of aggregates of 20 to 30 mm size up to 40% of volume, the density of soil increases. So by the studies, we can know that with addition of 20 to 30 mm size aggregates up to 40% of volume, the density of soil will increase. After that, there is no movement in density. So let us keep our session here. We will learn compaction furthermore in next video. Thank you.